Alright, and welcome to our next section, the OAR drill. This will be a little bit different from the nano drill we just did. Now, the setup that I have that you're about to see is looks rather complicated, but in essence is really not. Especially if the variables are very clear to you. You can see how everything just kind of falls together in place. Now there's a theme variable kind of going on with the OAR drill, and it's the main variable is actually energy. Okay, how to translate mechanical energy. A little bit of history on the OAR drill. What you should know is the Seesaw Drill, which you're going to see later, came before the OAR drill. They are related in a sense, as you'll see, but we're going in alphabetical order. So the OAR drill is going first. The OAR drill has to do with translating a class 1 lever, okay, a variation of a class 1 lever, and so is the Seesaw drill, but you'll see that they are variations off each other. So, but we're going to do the OAR drill first, and I think you'll find the setup a little fascinating and a bit of fun. So it does involve my oak reloading spindle that you've been seeing a few times, and so what we're going to try to do today is for the core 2, for the spindle reload, and for the base is pine, some lumber pine, and see if we can't get this going for you and keeping it fun. Alright, I'm going to show you all the parts now and how this gets thrown together. We're going to mate it, warm it up, and hopefully get it lit. Okay, here we go. Alright, so this is my OAR drill and Seesaw drill setup, by the way, on the side of the fire dojo. We're going to get some close-ups in on that in a second, but here I have a paddle, okay, and by definition of an OAR, I believe, is that the paddle has to be connected to the side of a boat. So with a paddle, that's freehand, right, like this, and the top of a paddle, that's usually your fulcrum, okay? Remember, FRE 1, 2, 3. So the effort is in the middle, and the resistance is on the end. So that's how you use a paddle. But an OAR is a class 1 lever, and it's connected to the boat in the center, right? So there's your fulcrum. your effort is on top, right? Because this is connected to the boat here. And you would row this way, and the resistance would be on the end as the water is in the paddle is in the water. So what we're trying to do is translate that class 1 lever the mechanical energy of that. Let's take this off. I'm going to flip this camera around. Now this is both the seesaw. You're looking at the seesaw. This is the seesaw. Seesaw drill, which you're going to see later. This is the OAR drill. And as you can see, the fulcrum is in the center. Here where my hand is here, this is the effort. And the end, where the rope is tied, is the resistance. Now, the main complication that I really had with translating this mechanical energy is as the oar swings, it's in an arc. So it kind of goes in a circle, okay? So it's not a straight line. So in order to translate that, I had to put pulleys. 1, 2, 3, 4. Okay, so 1, 2, here's the shelf, 3, 4. Okay, so there's 4. And you could, as I scan around, you can see my mess in here. My mad scientist laboratory. And here, connected to pillar on the fire dojo, is the OAR and the Seesaw Drill structures. Now, here this beam, supported by that beam that goes across, keeps the shelf up and supported. Okay, I have some 2x3s here that come off the sides. They're screwed in, and it's kind of a recessed shelf. Now this doesn't need to be here. This is kind of just filling in space. Okay, I have some bamboo pieces that are glued in there to kind of fill in some space. But here I have written what size the base is. 1 5/8 by 3 inches, which is what this is. 1 5/8 by 3 inches. Piece of pine. And that fits right in there, into that slot. Here I have a little door that acts as 2 things. Holds the base in, so the base doesn't go anywhere, but also acts as a containment for the notch. Because what we're going to do is we're going to put a notch in here, and it's going to catch all the dust. So the dust doesn't go anywhere. So that has 2 functions, not just 1. Alright? And I wrote a note here that a box notch worked fairly well last time. So, and with my notes here, March 23rd, 2011, the first seesaw coal, and 2 days later, on the 25th, with yucca and Atlantic white cedar, we did the created the OAR drill. So the seesaw drill was first, and the OAR drill came next, 2 days later. Once I realized I could translate this energy of the seesaw drill, I knew that I could translate the energy of the OAR drill as a different type of lever. So how does this get strung? Okay, well, this line goes around that pulley and up to this one. Okay. And then we do the other side. This line goes here up there. So now, so here the action goes back and forth between these two pulleys, okay, just like this, which gets translated up here to these two and goes across the shelf. Okay, now up here we have a very familiar type of class 2 lever. The resistance is in the middle, the effort is on the end, and that's created by this weight, and the fulcrum is in the back, as you can see by the hinge. Okay, and we have our little classic copper cap, which is epoxied and nailed in all together. Okay. So how this looks is we take the oak reloading spindle that fits in the copper cap. That'll go and fit and mate there. Okay. And now what you need to do is the string needs to be aligned between the two pulleys. Because if you can remember from other drill devices where the alignment is not correct, such as the lathe drill, the drill will drift. It will drift away from the mating and move in either direction of where the unilateral force is taking place. Okay, so we don't want that. So this was really the problem that I had to translate. So because I knew this OAR motion, this mechanical energy, was moving in a circular arc, I had to straighten out that line. Had to straighten out that line for the spindle. Okay, so here I have my pine reload, spindle reload in there. So what we're going to do is we're going to wrap this around, take about 7 or 8 times, and get this cord really have some good tension on there, and get this thing mated. Now I'll show you how the weight goes on once I get this set up. And by the way, on the nailed to the side of my fire dojo here we have the first Seesaw base. As you can see, it's March 23rd, Wednesday, and below it is the OAR drill on the 25th, and that's the base. So those were the first coals I did with that, so they're kind of kept in, nailed to the side of the fire dojo as a reminder. Alright, so let me get this all set up. We'll get the weight on, we'll get this mated, we'll carve the notch, and let's get us a coal. Alright, be right back. Okay, so I have the reloading spindle attached to the pulleys. Now, if I had my way to do this over again, okay, I would lower one pulley. Because as you can see, when one pulley goes on and wraps around multiple times, the string doesn't come off exactly that same spot. It actually comes off lower. So what I would do is actually lower the pulley below another one. Okay, if I could do this over. Because this is a science. This is how you learn. It does stay. It does work well, nonetheless. But I think I would alter that a little bit. It's just like when you're doing a bow drill and you need to angle the bow so that the string rides up and down the spindle. See, here I have a 6.5 kilo weight, which is about a little over 14 pounds. And these strings that I have here tied to the pillars are my safety. And what I mean by that is this weight hangs on this screw for the lever. Okay, now heaven forbid I'm down here doing the OAR motion and this gets kicked off and falls. Well, this is my safety, so that doesn't kill anybody, that doesn't hurt anybody. All right, that's why that's tied there. So we're going to hook this up here, and we're going to back up and get a view, hopefully, of everything working. I'm going to turn this on its side again. So we're going to flip the camera a little bit. Okay. I'm going to try and get as much of this as we can in frame. Alright, so this is wrapped around 7 or 8 times, and again, effort, fulcrum, resistance, okay, and then we try to keep the alignment of the cord so that we reduce drift. We have our pressure applied by the weight and the class 2 lever, and let's give it a shot, shall we? And you can see how that works. So what I'm going to do is turn the camera around this way. We're going to turn it back on its side again. And you're going to get the... What should we do? Let's do it this way. Yeah, let's do it that way. Okay. Let's get a little bit of speed to increase the temperature. Starting to smoke. So it's starting to mate. Okay. All right. And there we go. Could smell the burning pine. All right, so I'm going to put a notch in this, and we're going to see if we can't get a coal. All right, be right back. Okay, so I've placed a box notch in our base, and it's going to fit right in there. And of course, we have to wrap this back up, so that's what we're going to do. Now, when you wrap this back up, one of the things you have to do is get your OAR centered. Oops. Get your OAR in the center before you begin. So your OAR needs to be straight and straightened out with your spindle. Here. Because if you start off with the OAR off to one side, you're going to limit your own space as a variable. Okay, so the cord won't have been properly aligned. It's like if you were working a bow drill, you could only use a couple inches of space within the bow, and that doesn't make any sense. So just make sure everything is aligned. See, with all the drill methods, alignment is really the key. screwdriver. So you have to make all these little adjustments. There we go. Make sure the cord is together. Now what I'm going to do is take a little bit of jute and we're going to fill some of that space of the box notch. And we put our containment lever back to hold the base and to trap the coal dust. Let's put our weight on. Okay. So what I'm going to do now is I'm going to raise the camera up a little bit. Give me a second. And we're going to get a better view of the notch filling. Now my structure, the screws are weakening on the fire dojo. So the whole fire dojo actually shifts back and forth if you hadn't noticed. Alright, so let's... I didn't mention it, but the drill, the reload, I've taken out the dead space center, so that's not there, and I've cut it again flat, so in a way it needs to be remated again. So we're remating, warming up, and actually going for the coal. A little bit more speed. It's filling with dust. Let's keep it nice and steady. Let's just keep going. Keep going, keep going, keep going. See if this pine works for us. See, it's kicking up dust. And I don't see anything. We sure got a lot of dust, but it didn't reach the temperature that we needed for it to ignite. I mean, the dust looks perfect. I'm going to take this weight off. I might need to change the woods that we're using to something else. Now, the original coal I got with the OAR drill was a yucca on Atlantic white cedar. So if you can see the sphering on that, whoops, you can see the sphering on that, even with the dead space gone. Okay, and that got a lot shorter from where it started from. Let's take that out. It sure did kick up a lot of dust, didn't it? And there is a lot of dust there. And the dust looks perfect. It's dark, it's powdery. However, we didn't get it to ignite. So what that means is it wasn't able to reach the temperature that was required. So I may need to lower the threshold of the hardness of the wood in this instance. So let's change the woods. Be right back. Okay, so I made a few changes. Our spindle reload is now yucca, and it's going to be a solid. I'm not going to take out the dead space center. And this is a leftover base from the lathe drill, so it's sodal. So I carved out the divot for that. Now the other thing too is that this is smaller than the space that fits inside here. It's less than 1 5/8 across. So what I'm going to do is take 2 more pieces of bamboo, and they're going to fit in the sides here to take up that space. And to make sure it fits really well, I'm going to make sure that doesn't go anywhere with a nail. So let's rewrap our drill, and remember to align the OAR so that it is straight as this wraps. Okay, get all the way down. Now, the string not only needs to be aligned this way between the pulleys, so pulley, spindle, pulley, it also needs to be aligned along this plane. So not just A, B, C, but also where the line comes off the pulley, here, okay, it needs to be somewhat between here and the next pulley, okay, the top of that, where that comes off. And again, if I had my way to do it over again, the pulley would be a little lower on one side than the other. Is that tight enough? Nope, I don't think so. Is that tight enough? I think that's tight enough, at least for yucca and sodal. Now, we've lowered the hardness of the wood, so we've lowered the threshold as the temperature needed, that's necessary. So let's make this together, see how this goes. Still some serious unilateral force. Move the camera over a little bit. It's in the way of the OAR, actually. Smell it burning. Hear that stutter? It means I don't have enough wraps. But I'm going to call that mated. Okay. So let's put our notch in and let's get going. Now I've got everything set up and back inside, and this is the dust left over from the Atlantic white cedar. So what we're going to do is we're going to fill that up with that and reuse that. And that'll save a little bit for us. Okay. I'm going to put one more wrap around the spindle. That was that stutter you were hearing. Because what happens is it was picking up the slack of the cord between strokes. Alright, so I'm going to back this up, and I'm going to flip the camera on its side. just get everything into view. And then what we're going to do is, when I think we're ready, I'm going to bring the camera back and show you the results. Okay. Now here's what I really want to explain about the OAR drill. Okay, as different from the Seesaw Drill. Okay, if you were to take the OAR and split it in half down the center, okay, what I'm basically doing is when you do an OAR on a boat, okay, the effort and the resistance always stay on the same side. Okay, so if I'm pulling a boat, okay, here on the end with the OAR, I create the effort going this way and the resistance goes out, right? Let's get that in frame. If the OAR is connected to the boat here, and I have this end here, okay, the effort goes toward me and the resistance goes away, right? Then the OAR comes out of the water and we repeat the process. So the effort goes toward me and the resistance goes away. So there's your classic class 1 lever. However, the difference here is we're doing a back and forth motion, not just a one direction motion, it's going back and forth. So the difference here, and I'm going to clarify this again with the Seesaw Drill, how that is different, is that I'm doing not just toward me, but in a way I'm changing positions and going this way, and then I'm going this way, and then I'm going this way. So the effort is on both sides of the same side of the lever, okay? It'll be different on the Seesaw, which I'll explain later. But here, the effort stays on this side. The resistance stays on that side, okay? Effort, resistance, and that doesn't change. You know, but in the difference between how you would use an OAR on a boat is that it's going back and forth instead of the resistance just going in one motion. Okay? Effort, pull. Effort, pull. Here we're doing effort, push, and pull on the same side. Okay? Alright, here we go. See the smoke rising. Oh, there goes my hat. We have our coal. Yes, we do. All right. So what we had to do was lower the threshold of the wood in this instance. And as you can see, that this doorway held all the coal dust in there very well, along with the base. Very nice. Alright. Yoka on Soro as core 2. Alright. Now we're gonna move past P, which of course is the pump drill, which we did in the primary basics. And we're gonna do something really odd, the Kapla drill. What is Kapla? Well, I'll explain that next as we move on to Q. Alright, let's keep going.